As I've anticipated in the first video where I presented and demoed my Motorized Fader project, in this new video I'm going to show the schematic of the circuit that I've designed and prototyped to control the faders. As I said, the circuit is based upon the microchip SAMD 11 MCU here, which is an MCU developed around the ARM Cortex M0 Plus processor and comes in my case with SOIC 20 package, so 20 leads. Then we have a single channel motor controller, namely the BD6221F, actually here is marked 20 but it's 21, which comes in SOP 8 package and controls the DC motor of the fader. I'm showing the schematic and then I will show the board into Eagle, which is the CAD application that I use to design electronic circuits. At the very right here, we have the 4 through-hole connectors to be soldered onto the motorized fader, with the ground here and the positive here of the 2 tape linear potentiometers available in the motorized fader. Then we have 2 more through-hole connectors here for output lines of the 2 potentiometers, which are wired with the MCU via pin PA14 here and pin PA15. And these 2 pins are connected inside the MCU to the ADC device. Finally, there is a last through-hole connector here for the capacitive touch feature, which is wired to PA16 here on the MCU via 20K resistor. This pin is implemented in the PTC channel, where the PTC is the capacitive touch device inside the SAMD 11 MCU. Moving on, we have 3 groups here and here of headers for power supply and connectivity of the board with the outside. Starting from the first group here, we have the 9 volts line here that is powering up the IC motor driver and the DC motor. Then we have 3.3 volts line here to power up the MCU and LEDs, and finally the ground here. Then we have the second group. The second group is all about SWD interface to program and debug the MCU, with the reset line here connected to PA28, with the SWD clock here connected to PA30, and finally SWD I/O input-output connected to PA31 here. Finally, the last group is for serial communication. And then, as you can see, it was originally thought to manage the I2C interface, but then I changed it to UART for the reason that I have explained in the other video. In particular, SCL here is the RX of the UART, and SDA here is the TX of the UART. These are connected RX to PA23 and TX to PA22. These are the 2 paths for the SERCOM1 device. The SERCOM is the device inside the MCU managing serial communication. In the middle here, there is a momentary button to reset the circuit. This switch connects to the reset line of the MCU here, and via 10K resistor here connects to ground. Moving on, we have the LEDs on the board. We have 4 LEDs on board. First one here, it's a red LED wired via 10K resistor to PA9 on the MCU here, and then connected to ground, of course. This is the LED lighting up when the touch is detected. Then we have a second LED here, which is an orange one, which I have called operation. This LED blinks when the motorized fader is moving autonomously via feedback, and it's wired to PA8 here via a resistor for 220 ohms. Then we have a green LED, which is the power LED. This LED lights up to show that the circuit is operational. This is connected to PA5 through a 10K resistor and then to ground. And the last one is a blue LED, which is connected to PA4 pin through a 10K resistor and then to ground. This LED, I call it a test LED, lights up, for instance, when there are error callbacks or other conditions useful for debug purpose without to move into the debug mode. One note about the resistor values. These values vary based on the LED lighting power, and it was set really in a purely empiric way. I just don't like to have too strong lights on the board when I work on it, because after a while it becomes a bit annoying. Then we have two more lines, 17 and 16. These are the VDD and ground. VDD is connected to an MLCC decoupling capacitor for 0.1 microfarads. To close the MCU view, we have the we have this line, which is PA3. This is the voltage reference for the ADC. And then we have three free pins, which are PA24, 25 and 02, which for the moment are not connected. Then moving to the left, we have the motor driver here. Here we have pin 6, 2 and 3 connected to VCC, so it's 9 volt. Again, these are connected to an MLCC capacitor here for 10 microfarads. Here probably I will change the MLCC capacitor with a polarized electrolytic one. Then we have pins 4 and 5, which are connected to PA6 and PA7 on the MCU. These are the forward in and reverse in, and these are controlled by the MCU via timer PWM. Then we have pin 1 and 7. These are the outputs connected of the motor driver, connected to the JST header, which then connects to the DC motor. Last thing, there are two more through-hole connector here. These also are to be soldered on the motorized fader, and for the moment are isolated, so not connected. Probably I will then connect them to a line of the MCU to exploit the new shielding feature of the microchip QTouch library for capacitive touch feature. Let's finally have a look to the board. This is the board. It's for a double-sided PCB. As you can see, all the components are SMD and are all soldered inside the top side of the PCB. Grounding is present on both sides, and the two ground plates are connected through vias. That is all. In the next video I will show the code I have written to control the MCU and all the configuration done via the Atmel Start interface. I hope this video can be useful for someone, and I will be happy to receive suggestions on how to improve this design if someone will be willing to provide. Thanks for listening.